Okay. I would say we got full house, so we can get started a minute early. Thank you so much for joining me here. Everyone set up? Perfect. As said, we got full house, so let's start a minute early, so we got an extra minute. And thank you so much for joining me on two of my favorite topics here, knowledge graphs and machine learning / large language models. And today we're going to talk about how can we cross this gap. So I feel like it seems like two very separate fields, like large language models, ChatGPT, Llama 2, etc. Probably the biggest hype of 2023. On the other hand, we got knowledge graphs, a very structured knowledge bases in general. And today we're going to talk about how can we cross the gap in between those two technologies, or how can we even generate more value, business value out of them. So what is the challenge out here? So on the one hand, we got those large language models, like a probabilistic language model, which is really great. We can chat with that, we can ask any natural language questions, and we'll get an answer. Kind of the downside of those models is they only have general knowledge. Basically, those models have been trained on internet data. I think ChatGPT just has been updated this week to data till 2022, early 2022, but it's kind of only that data set. And on the other hand, it's also prone to hallucination. I'm not really sure what is the answer I'm getting, is it correct, or is it something the large language model has made up? Because underlying the knowledge in this large language model is actually probabilistic and it's unstructured. So while on the one hand it's great the large language model contains all that data, it's not as clearly accessible as the rest. And if you think about it, we actually nowadays, if we use ChatGPT, we leverage it for two different functionalities or two different goals in mind. First goal is we want the natural language interface. We want something understanding my natural language question, and I actually want a question returned in natural language as well. The second part is that we also query the knowledge stored inside ChatGPT for now, and this might not always be correct, as said, hallucinations or also unclear answers. Then we got knowledge graphs on the other side, seemingly kind of the opposite. So knowledge graphs, they represent very structured data. So often companies, if you think about also Google, Facebook, they have very big knowledge graphs storing structured domain-specific data. And I can kind of query that and get results in a very concise way and a very precise answer. And it's kind of we would actually like to combine those two properties, where on the one hand I got my structured knowledge, often domain-specific knowledge, also I don't want to share that with the public because it might be my very private specific data within my company, within my entity, and I don't necessarily want that accessible to all the internet and ChatGPT or whatever model out there. And this is what today's talk is about. How can we combine those two technologies and actually get more out of them in the end? And ARANGODB, we are a graph database out here. We are actually doing that. So we are leveraging those large language models as a natural language interface to our data sets. And I think if I had to phrase it like that, is we actually enable access to the data stored in various formats through a very natural, very easy way. And we'll see that throughout this presentation. Quickly about myself, I'm JORG, I'm CTO at ARANGODB. Basically have been doing database systems for the past, I believe 17 years. Started out a long time ago with a PhD in that field, built a lot of data infrastructure, both in Europe, but also in Silicon Valley, and really like databases, and especially right now what I enjoy, I can kind of live that combination of machine learning, analytics, and database all within one role, so pretty happy about that. You might wonder, ARANGODB, graph database, why do we actually care about large language models, and why do we care about that intersection? So as mentioned, ARANGODB, we are an open core graph database. We are very scalable. Largest deployments have over 50 nodes. And I think a core differentiator is also we are transparent in our charting. So you don't have to worry about how many nodes there are. We're simply going to take care of it for you under the cover. In addition to that, often a graph database, this is about storing and retrieving connected data, but there's a lot around that. So there's graph analytics, where I want to analyze those data sets, for example, entity resolution, fraud detection, etc. And we also, and we'll talk about that tomorrow here as well, also our graph machine learning offering, where we're leveraging really state-of-the-art graph neural networks to also extract value out of your connected data sets. But where are the challenges, and why do we care about large language models? And this is exactly about how can we make that accessible to a larger number of people. Most of us, we've learned SQL like someday back at school, back at college, back at university, but few of us actually dealt with graph models out here. And so there has been a paper also describing a lot of what we are doing here. And I think what's really interesting is the knowledge graph enhanced, or the augmentation of knowledge graphs using LLMs. If you haven't heard about those terms, don't worry, we'll go into more detail. But if you want like more details and more of the theoretical background, I can just recommend this paper out here. But in short, what do we want to do? We got data set stored in ARANGODB. On the right side, we got some users who want to access that data set. They don't really know about like how is it stored, how is it structured. They just want to get a result out of it. They don't want to worry about, is it the shortest path algorithm, or which field do I actually need. They just want to have like a non-expert answer out of the system. I think this is the part one of basically accessing existing data sets through large language models. On the other hand, we also have our knowledge graphs here, which need to be created. So typically there's an expert team who's going in, they take data from various data sources, data lakes, relational databases, API endpoints, etc., and they all kind of construct the knowledge graph out of it. This is another challenge where you currently need expert data creating those knowledge graphs, but again, large language models can help us with that, and we'll see how this is working out. Quickly about knowledge graphs, I would call them like a little more structured data warehouse of graphs. It's a representation of real-world objects. So for example, in supply chain management, we got really huge knowledge graphs being stored on ARANGODB, and you can harmonize the data from multiple sources inside this like one canonical model. And therefore, for example, entity resolution is a really important term. I might have in different data sources, I might have the same representation. I want to combine that into like one coherent knowledge graph I can query across my company, across like my entity out there. Examples are, for example, Google has a large knowledge graph, DVpedia is a semantic web version of Wikipedia, Facebook has a graph out there, there's an Amazon product graph. So there are a lot of different versions of that, also publicly accessible. It basically comes down to like what we have here. So this is like from the Cora data set. I have different entities. So I got papers. Papers have a title, authors, a year published at a conference. And those are different entities in a graph. And then I have connections in between. So from a graph perspective, a knowledge graph basically is just a heterogeneous graph where I have different node types and different edge types I can then query and do inference on top of. What is the status quo of dealing with those knowledge graphs? Right now, as mentioned, there's like an expert user here on the right, and then I have like business analysts who often want to get outputs from it. Sometimes those business analysts, they actually know how to write like a very query to actually retrieve it, but most of the time we have to rely on the expert team. And this becomes a bottleneck in small and large organizations because I have to rely on this expert knowledge. Imagine like your CEO wanting to know like, hey, what are the latest numbers? What about this malware attack? They basically would have to go in and ask the expert, whereas ideally they could just ask that natural language question and get an answer out of it. And this is where basically LLMs are coming in to help us. So we actually tested out-of-the-box LLM performance, so both ChatGPT or GPT 3.5 and GPT 4.0, and we actually got pretty impressive results by just generating the queries out of it. And again, as said, like we'll see that. So using out-of-the-box LLMs, we can already get really good performance and generate queries to to basically make the underlying data representation, the query language, and all the kind of like expert knowledge required around graphs transparent as well. Kind of once you're done with that, you still want to get better results. And this is basically kind of like the hierarchy. I'm a bit careful with that term because I feel like those different techniques can be used for like different goals. But we basically have different options. So the first one is just prompt engineering. Probably most of you heard about prompt engineering at one point, right? I go in, I try to provide more context. So for example, please answer as a data scientist, or please consider this and this knowledge. So you're trying to kind of like make the LLM more specific by providing context around your query. Once you're done with that and you exceeded like all the gains you can get from it, you typically turn to other models. So for example, like you can go in and fine-tune an existing base model. We'll talk about that later. You could even go in and train an LLM from scratch. I would highly not recommend doing that. But for example, especially the fine-tuning, OpenAI is having like an own endpoint for you to do that, so you don't have to build the infrastructure from scratch. It's quite easy nowadays. But I think the one thing where most of us can get most benefit out of is RAG, or Retrieval Augmented Generation. And what does that basically mean? We said earlier, the large language model, it comes with like two different functionalities. One functionality is about understanding natural language. The other functionality is the knowledge. And basically with Retrieval Augmented Generation, we're separating those two fields. So how does it basically work? I still have my base model here, right? This is trained, this can be just in GPT-4, Llama, just out-of-the-box LLM. But now, instead of querying the knowledge, so the user talking to the LLM and telling the LLM, hey, retrieve that, it's actually talking to an endpoint which will fetch data from a knowledge base. So in our talk here, we consider a knowledge graph. That knowledge is taken by the LLM and then actually put together and actually condensed, and I get a natural language answer. So you can already see we are leveraging the large language model for its natural language capacity, but not just for the core knowledge in it. This is what we try to retrieve from an external knowledge base, and this gives multiple advantages. So I think the first big advantage, I see most people wanting that, is to actually have answer evidence. So we talked about this hallucination problem, like with the knowledge stored in an LLM, I might just get like blatantly random answers which are just not true or which have never been like in the base model. And by providing answer evidence, so basically the language model, like when it returns a response to the user, it can be like, hey, this is from this and this document. You can look it up if you actually want to like dig deeper, or if you need like some evidence for this answer. So I think this is like the one big advantage of getting reliable outputs. The other one is, with those evidence, I can also, of course, have interpretability. I'm not just relying on like a probabilistic answer, I actually can trace it back. So if I'm in a medical field or in a financial field, often this is really important, where I can say like, this answer has been generated because of this, and it's not just like randomly made up, but it can actually provide evidence for that. The second biggest reason why I see people interested in that is the combination with custom data. I want the powers of the large language model, but I want it together with my own data, with my custom data, which is private. I don't want to share that, but I basically want the same capability of the large language model together with that. And together with that, or as a side effect, I also can keep up-to-date data. As said earlier, ChatGPT, I think now it's up to like January 2022. If I need more up-to-date data, I can provide that myself with that. From an operation standpoint, I don't have to train my own model. I can take an out-of-the-box Llama 2, GPT-4 model. So it becomes a lot easier. I just have to connect it to kind of like my own data sources. Second option out here is fine-tuning an LLM. So here I take my base LLM, I generate the training set, and then I actually fine-tune the usually like a few layers in that neural network to get better results. And both of those techniques, they're very powerful, but typically, for example, we use both. We use the retrieval augmentation, but we also use fine-tuning a model, but for different purposes. So if I just switch back here, this allows me to extend an LLM with my custom data, with custom knowledge. Whereas fine-tuning, on the other hand, allows me to specify like different capabilities or kind of like different tasks the neural network might not be aware about. And so, for example, an example where we started to use it is to translate between different query languages. So AQL is kind of like our query language, and we wanted to take another graph query language and translate into that. We started out by just prompt engineering, but then as it's a pretty specific task, we actually went in and started fine-tuning our own model out there. So I think this is kind of like the difference where I feel we need to separate what are we talking about with LLMs. Are we talking about the task-specific capabilities, or are we talking about the knowledge being stored in there? And exactly with that, if I just jump back here for a second, wait. I wanted to jump back here. I think this is exactly where we have different ways of customization. Prompt engineering can kind of do both, help me to specify what kind of task I want to solve. Retrieval augmentation is helping me extend it with custom knowledge. This helps me to really focus on fine-tuning for a particular task. And then really like the last resort, I would highly recommend everyone not to do that. I can also train an LLM from scratch if I really, really need to. Okay, so far we kind of like talked about like how can I query an existing database. Let's actually move to that. The next task out here is how can I generate knowledge graphs? So how can I take existing data sources and kind of create that knowledge graph out there? And so it's challenging if I look out there. So imagine like from Wikipedia, from like free text forms, we want to generate this kind of graph where we know about certain entities, where we know about the relations in between, and where we also know like, hey, are we actually talking about the same entity out there? So the kind of like deduplication out there. And so this is where large language models, they can help us, first of all, in the entity resolution, the entity discovery, like, hey, find me all the entities, Barack Obama, USA, etc., from a free text form, from a source, from any document out there, from a Wikipedia page, etc. Then also, next step is then figure out all the relationships in between. So what are the different relationship types I have present in my data set, and how can I map them over to the knowledge graph? And I think this is then when the second level comes in. I say it's about the semantic here. So for example, like born in, this is an edge, a relationship with a pretty particular semantic. And typically in those knowledge graphs, I already have a notion, I already have like an ontology, I have a vocabulary saying like, I know the semantics of what an edge born in means. So I actually not just want to extract like born in, but I want to extract like, hey, it's actually like this type of relationship out there. And again, this is where large language models can take unstructured input text and help me generate this knowledge graph out here. I don't think it's ever going to replace the experts we saw earlier, but I think it can really, really help in generating those knowledge graphs out there. So it can kind of be a support function enabling much higher productivity. And then also, once I have that, I can do like all my different tasks. So for example, then I'm in that world of knowledge graphs. I can do missing relations, and again, I can also then feed that back in natural language to my core database, right? I mean, now we're in the knowledge graph. I might actually go back and expand the Wikipedia article about these kind of edges once I've discovered them in the knowledge graph. So it's kind of like, it's a feedback loop where we go from our unstructured data, from our natural language representation to knowledge graph and back potentially. Okay, quickly, what is like some of the other magic behind that when we do that? We often, and large language models do that as well. We all heard about vector stores. Vector stores, embeddings is just a fancy term for like the vectors being embedded there. And what it means, I want to take like my graph, or I want to take my natural language representation and turn it into a vector, turn it into embedding. And then in that embedding space, I can actually take natural language, or I can take graph. So in this space, it doesn't matter where it's coming from. Is it coming from a graph? Am I going back? Am I decoding back into a graph? Or am I coming from a natural language representation? You might have seen those endpoints on ChatGPT where it's like, give me an embedding. And this is exactly like, if I'm in this embedding space, this is kind of the connecting glue in between the different worlds of text, natural language, and those knowledge graphs. So, how does kind of like the end vision look like? So in the end vision, I actually have my business users. They can use natural language to query everything. They don't have to do any cycles back and forth with the expert to get the answers. And on the other hand, also my experts, when generating the knowledge graph, as said, I'll still need those people around, but they can be much more efficient and much faster taking data out of all those different data sources, turning them into a knowledge graph by the support of those large language models. And I think this is the implicit power if we talk about the graph space. As said, we'll have a talk tomorrow about graph machine learning, and I call it like graph thinking, or why connected data is so powerful. It's basically, we live in a connected world and we want to exploit data in that way as well. And traditional machine learning, traditional analytics is just often ignoring the connection between data by assuming that it's independent. And I think they're really graph models, graph machine learning, graph analytics, graph databases are very powerful, but currently they're just, it's a higher bar in terms of using them. And I really feel large language models can help us to make that power of graph much more accessible by a larger audience, by a non-technical audience out there. Okay, let's get a bit more practical. That was like a lot of theory. I hope I convinced you why this combination is so powerful, but let's get a bit more hands-on. So there's LangChain, and LangChain is kind of the Swiss Army knife in the LLM space out there. So they have a lot of integrations, amongst others, ARANGODB out there, and that actually allows you to very easily connect your large language model to, for example, ARANGODB in this case. So you don't have to know like much details. You can just follow that. If you're in this framework, you can just leverage that to go out there. And what I wanted to show is just kind of a quick demo. Maybe up front, if you want to do that yourself, this is all open source of the LangChain documentation here. So if you just go to LangChain and search for the ARANGODB integration, this is what you'll get. But quickly back. So here's a very simple graph. I think that's even sampled down from Games of Thrones and kind of the relationships between characters. It's a toy data set, but I think it really helps us to go into details what we want to get out of it. This is stored in ARANGODB. Great, we can visualize it, we can deal with that, but how can I now do queries against that? If we connect that over to the data science world, there's Jupyter Notebooks. There's also, we have like a chatbot to do that. But now I can basically go in, and I hope this is still valid, and basically just run all my different chains here. And you see, it's a very simple setup. I don't need to know much about the underlying system. I can go in, and I hope the connection is still up and running. Of course, I'm hitting the rate limit. Damn it. I love live demos. I'm hitting the rate limit of GPT-4 here. So I just I exceeded my current quota and need to check my billing details. But then let me just run through. This is live demos per se. It's probably because I ran it before. Let me just stop that. Cancel. But basically what it allows me to do, it actually allows me to answer live questions and get natural language answers out of it. So I think this is what we're using here is just a ChatGPT default model, so no modifications. In our experience, and I would recommend that to anyone leveraging large language models out there, is to use chain modifiers. Yeah, I know, because I exceeded that. And this is, in particular, you can see it as kind of prompt engineering. This is to give some examples. So if we hadn't exceeded our limits with OpenAI, we would have gotten like some answers, and we can even see like which are the generated queries. And by default, we actually, like this was, we were very surprised and impressed. We get out of the box really good answers, but the queries often are not optimal. So what we started to do with those non-optimal queries, as said, we got the right outcome, but it was just a very obscure query being generated. We gave it certain examples like, hey, for this question, hey, this is actually the answer which should be returned, or this is the query you should generate. And with that, with a few examples, you can really improve those large language models. I think this is really the power of large language models. It's called few-shot learning. So just by providing a few examples out there, I can really improve the outcomes I have. So I think that would kind of be my like, if you really want to get started with large language models, check the out-of-the-box performance, then try to fine-tune like certain weird results, and you will really see it improve over time. So I don't think you necessarily have to go to fine-tuning right away, but like prompt engineering, what this is, and then going to like the next level, actually connect to an external data system and decouple the knowledge from the natural language interface. I think this will give you most impact out for your bugs there. Okay, so internet is great. That was a very simple example. If you actually want to see more, so we have more demos also on our website about in different domains. For example, in the network asset management domain, in the fraud detection domain, in the cyber domain. Join our summit. We'll have more talks there. Or actually just visit our website. We got tutorials there. Or ask questions right now. Yeah. Huh? That's an online event. And now I have to use the headset myself, and I have to hear myself. This is like getting really annoying.
Hi, you hear me?
Yeah.
Oh, cool. You talk about that you need to map certain entity or certain data to a knowledge base. In this case, part of knowledge base that is the ontology you described before, right? And that you need some expert in doing that from the different sources. Does this can be done by ChatGPT?
Yeah. As said again, so you're talking about the knowledge graph construction, right? Yeah. So in the knowledge graph construction, if I have an existing ontology, the easiest and best outcomes we saw is if you actually generate a few examples, and then you use exactly the modifiers we just saw in the end. This can be simple prompt engineering, and you basically give it examples of like, hey, which natural language entity corresponds to which ontology concept, right? And with a few examples, I said this is really powerful with those large language models. If you just give it a few examples, you get pretty powerful outcomes there.
Yes, sorry, I have another question. So if I have lots of unstructured data, let's say a large PDF document,
yep.
I do have the option of splitting up the text into chunks and do the vector embeddings in the vector store. Or I do have the option to create a knowledge graph out of it and store it in the graph database.
Yep.
And in both these cases, we are doing augmented retrieval to answer the questions. So what's the difference between these two if an LLM is answering the question by referring to a vector store versus by referring to a vector database?
Yeah. So if you refer to a vector database, you'll get faster outcomes because you don't have to translate it again, right? On the other hand, what you're sacrificing, I think we said like we want certain, the two biggest things we said we want to get is the avoid hallucination. You can do that to a certain degree with the vector store as well, but also the interpretability. So basically, if I go through a vector store, I kind of sacrifice the evidence provisioning. So I can't really have an interpretation of my results because I'm getting like a vector, right? And if I'm using a knowledge graph, I can actually get like hard factual outcome, for example, medical or financial domain. I think the other thing to keep in mind is how does it embed in a generic architecture? Like typically, I will actually, in most use cases, the knowledge graph itself will also be used by other applications, like updating it, retrieving data from it, so kind of like potentially even your operational database. With a vector store, you're duplicating that, and you have like a kind of abstraction of that. So you kind of need to keep everything in sync. So whereas with the knowledge graph, you actually have the most up-to-date representation of your data set. So I'm not saying like one solution is going to rule them all. They're probably like good solutions for, or like use the right tool for the right problem, right? So sometimes the vector store is the right tool, and others the knowledge graph.
Sorry, I have another question about your knowledge graph for database. I'm assuming we don't want to store this data into the actual database, graph database, and we have just the ontology. That would fit your model in any case, I can see.
Which data you don't want to store there?
All the source data, all the different heterogeneous data that you showed before.
No, I mean, you don't want to store everything, but like let's take the Wikipedia example, right? Wikipedia has like a lot of text, and there are only like few entities and relationships in between. So you want to extract the relevant information and store that in your knowledge graph.
Why if I have already there?
Huh?
Why if I have already there?
Because you want to, so you mean it's already there in Wikipedia, or? Yeah. I mean, because you want to query it in different ways. You want to query it in a structured way. I mean, you could ask your LLM to directly go to the Wikipedia article, but then, as said, you don't have the evidence, and you don't have the structured data access, which you can also leverage from other semantic applications out there.
So
yeah. Happy to discuss further. Yeah. Thank you very much.